Okay, so 4 key terms that we wanted to pick up on Thursday. Okay, so x-axis, y-intercept, and the milestone. Sorry, the turning point. Okay, similar to some of the milestones that we picked up on for straight line, and also some that we picked up on for trig graphs as well. Okay, so similar things we're talking about. We also talked about the shape. Okay, so if that x squared term is positive, okay, we're getting a smiley face. Okay, we're getting a happy face, a positive face. Okay, if it's negative, we're getting an unhappy face. Okay, so we're getting that different shape. That's the only difference with how we deal with that. So we looked at how we factorized that type of quadratic, getting rid of that negative sign. Okay, and then finding again the milestones, which are turning point, where the roots are, and where the y-intercept is. Okay, so we did that using a skill we already have, which was the factorization. So we did the common factor, we did difference of two squares sometimes come up, and we did the trinomials. Okay, and we were looking for that x term, and with that x term, well, we know where the y is anyway. Okay, so we could find that coordinate. Now, the questions, and we'll look at this later on, doesn't always show you a graph like this. Okay, it gives you a sort of storyline behind it and what these graphs are used for. Now, these graphs can be used for decisions. Okay, these graphs can be used for decisions. So, believe it or not, companies like Amazon will use these, or Nike, whatever, for pricing. Okay, so say the x-axis was the cost of something, so that as we go along the x-axis, that's the cost increasing, and the y-axis is the likelihood of someone buying it. Okay, and there's a sweet spot, okay, how much they can charge. Okay, so there's a maximum and minimum, so sort of where it crosses the x-axis is where its limits are, and that turning point, that maximum point, is sort of where the perfect decision is. So we can use this for decision making, and so we'll look at a couple of stories later on where that bears fruit, okay, in understanding. Okay, so we can use these in multiple different instances. Okay, so it doesn't always give you a graph like that, but it's very common that we will get that. Okay, so method one we spoke about was the factorization. Okay, pardon me. So just doing an example we did the other night. Okay, so just very quickly, when I'm talking about factorization, we're getting it in the form x squared 2x minus 15 equals 0. Okay, so we're getting a trinomial, we're getting a quadratic in that form. Okay, and we're trying to find the factors off of that. Okay, so we're trying to put that into brackets, and that will give us where it crosses that x-axis. Okay, that will give us our sort of our limits of where that graph is. Okay, so just going through that very quickly, so it's in our head. We're adding two terms together to get positive 2. Okay, we're multiplying two numbers together to get negative 15. To get a negative, we need to have a positive or a negative, or a negative and a positive. Okay, and it's just a case of going through all the factors of that. So all the pairs of numbers that you could use to make 15. Okay, you can't use 2, you can use 3, okay, 4 and 5. Okay, so that's only 2. We're trying to make positive 2. So you'd have plus 5, negative 3, and that would be your factors. And then you just put them in the form x minus 3, x plus 5. Okay, that would give you your roots. Oops. You'd split them up and then solve for x. Okay, so it would give you two roots. Okay, and that would give you a coordinate. Okay, so that's where that graph, if we were to draw out that, that's where it would cross the x-axis. Okay, so we did lots of examples in that on Thursday, and I sent you across a video on that. Okay, so hopefully those links worked okay that I sent in your email. Okay, so if anyone's not receiving emails, now's a very good time to tell me. Okay, so method one, to find the roots of the quadratic equation, you would use factorization, common factor, difference of two squares, and the trinomial, which I just did there. Okay. Method two, we use when the quadratic equations don't have exact roots. So when the roots where it crosses the x-axis is going to give you a decimal effectively. So you often see these in your calculator paper, okay? For the simple fact that you're going to get a decimal out the back of it. Okay, so you're going to get quite a difficult number out the back. Okay, so method two, oops. Okay, I'm going to use something called the quadratic equation. Okay, and this equation is used when the question.
So say in an exam, do we use one of these methods or is it both of them?
Not
So
one.
like step one,
Just
step
one.
two.
Just one.
Now.
Okay. Now, very good question. The quadratic equation can be used for any quadratic. Okay, but it comes down to how fast you need to be. Okay, so quadratic equation. Okay, it looks incorrectly spelled there, but that's because it is. Quadratic equation will work when the roots are whole numbers. Okay, but it does take slightly longer to do. Okay, so you would use it when the question mentions rounding, or if it says exact. Okay, so things like round to two significant figures, or give your answers to 2 decimal points. Or 2 decimal places. Okay, so if the question says something like that, it's looking for a decimal essentially. Okay, and then you won't be able to factorize easily, okay, or quickly. Okay. So we are working with equations in the form of ax squared plus bx plus c equals 0. Okay. Now, that a, that b, and that c, we're just using as stand-in positions where a number could be. Okay, so a, b, and c will change. Okay, so it's the form of ax squared plus bx plus c, but a, b, and c will change. Okay, and it's these a, b, and c that we're going to use as part of our equation. Okay, so your roots where it crosses the x-axis. Okay, sometimes referred to as solutions. Okay, so your roots or solutions, okay, are found with the following equation. It looks absolutely horrible, okay? But all it is taking those three numbers, one in front of the number in front of the x squared term, the number in front of the x term, and the number in front of the c term, and just being able to put them into position. Okay, now very, very importantly, given an exam, it's given to you, okay, it's given an exam formula sheet, okay, given an exam formula sheet. If you're not familiar with that, try and pull a past paper and just have a wee look at that formula sheet and just get comfortable with it and what it tells you, okay? But this equation, you don't have to memorize it, you just need to know how to use it, okay? There's a few key important steps when you're using this equation and solving with this equation. So I'll just give you that methodology first, and then we'll start introducing examples. Okay. Step one, is make sure that your original equation that you're working with, you have zero, the number zero on the right hand side. Okay, so we looked at an example of that, okay, on Thursday there, okay, where we had x squared and x term on the left hand side and we had another number on the right hand side. Everything has to go onto that left hand side and just leave zero on the right hand side, okay? Only then will it be in this format, so we need to use it in this format. Now at this point, putting it in order of x squared, x, and then the number will be quite useful, okay? And it will certainly allow you to see where the positives and negatives are, okay? So maybe put into order as well, okay? With x squared term first, okay? That just allows you to see where the negatives terms are, because the negatives are important, they have to come with you, okay? Two, what I would do is write ax squared plus bx plus c equals 0 below the full equation. Okay, so if you get given an equation, and we'll do this in an example shortly, write that below so you know exactly where A is, where B is, and where C is, okay, what you're pulling forward, okay? Just a wee reminder, you don't get any marks for that. Once you get good at it, you might not want to do that, you might want to skip that step, it takes 5 seconds, okay? 3, again, it's just a wee extra step, okay? Just write out on a separate line, okay, terms for A, B, and C, okay. Be careful looking for negatives. Okay. So you've got your equation, you've got that line ax squared equals ax squared plus bx plus c equals 0 underneath. What is A? What is B? What is C? Actually pull that out and write them out, then double check. Okay. At that point, okay, write out the formula. then input the numbers. Okay, so where it says B, input B. Where it says C, blah blah blah. Okay, again, we'll look at that. Now, there's a part of it that's quite important. Okay, and it's something, it's this aspect here. It's this b squared minus 4ac part. Okay, so what I would say is just do that at the side. So just take that to one side and just do that separately and then bring it back in. Okay. So again, this is just an extra step. An extra step I would say is worthwhile doing. Okay. So i.e. term under, oops, the root. Okay, so just calculate that bit separately, the term under the root sign. Okay, so the b squared minus 4ac, take that out. Okay, so put that back into the equation and then just solve through. Now this is an important step as well. This is a bit you do have to do. Separate into two different equations. Okay, so again, this will make sense in a second. What I mean by that is this step here. Okay, so we want to find two answers for x. Okay, so x equals negative b plus the root of b squared minus 4ac over 2a. And that also equals x equals negative b negative root b squared minus 4ac. Okay, so that positive, plus, and negative that you'll see in the equation in the formula sheet. Okay, that just indicates that you have to do that step twice. Okay, so you're working it out twice. So you're working out twice side by side to work out two separate roots. Okay, again, we'll look at it in a wee bit more depth when we go through it. Okay, step 8 is just solve. Okay, it looks like a lot of steps, but a lot of those steps are quite quick. Okay, a lot of those steps are quite quick. Important one is a separate, okay, and then just pulling it together how we use that data. Okay, so let's put that into an example. Let's put some numbers to it. Okay. Solve 2x squared plus 4x plus 1 equals 0. Give your answer to 2 decimal points. Okay, so let's go through that step by step. Okay, so we're solving a quadratic. Okay, it's asking us to give our answer to 2 decimal points. So immediately I'm looking at that and I'm thinking there's a quadratic, it's asking me for a decimal point, so I'm not going to factorize that. So if I tried to factorize that and go through our process, okay, I wouldn't be able to find exact numbers. Okay, so if we went through that process and tried to factorise that, don't write this down. We'd be adding together to make positive 4, multiplying together to make positive 2. Okay, positive, positive, negative, negative. We've only got 1 and 2. That doesn't work. Okay, so there must be another way of doing it. Okay, so it just simply doesn't work. You have to do it by the quadratic equation. Okay, so if we go through step by step, that's in the right order. Okay, now in the question, if I'm answering an exam, just write that out again. 2x squared plus 4x plus 1. I don't need to rearrange it. I've got 0 on that side. Okay, the numbers are in the correct order. So I've got x squared, 4x, x squared, x, and then the number. Okay, so if I then write ax squared plus bx plus c equals 0, I can very quickly just extract the numbers I need. So a is equal to 2, b is equal to 4, and c is equal to 1. That's the numbers I'm going to put into my equation. Okay, so the equation, x equals negative b plus or minus root b squared minus 4ac over 2a. Okay, just double check that. Okay, remember, you're given that, but now it's a case of putting those numbers in. Okay, so x is equal to negative b. B is 4, so 4 in there, plus or minus root of 4 squared minus 4 times a is 2, c is 1. Okay, over 2 times 2. Okay, now I said, just for simplicity and keep yourself right, take this wee bit out. Okay, this, you don't have to do this, okay, but it just keeps you right. B squared minus 4ac, so 4 squared minus 4 times 2 times 1, so 16 minus 4 times 2 is 8, times 1 is still 8. Okay, so it's 8. Okay, and I can substitute that back in. So I've just worked out under that, I've just worked out what the number is under that root. Okay. And just tidied that up a wee bit, so it looks a wee bit more digestible. Okay, now that bit on the right hand side serves another purpose as well. Okay, and we'll come back to that in a second. Okay. So this stage, we've still got this positive and negative thing. Okay, so we need to separate that, we need to break that up. Okay, so that gives us our two terms. That means x is equal to negative 4 plus root 8 over 4. That also means that x is equal to negative 4 negative root 8 over 4. Okay, so it gives you two terms. So remember what x is. X is where it crosses the x-axis. So at what point does that shape cross the x-axis? Okay, well, it crosses it at 2 points because of the shape of it, the parabola shape. Okay. Okay, it crosses it at 2 points, so you're finding 2 points of x. So putting that into your calculator, okay, have a wee bash at that. Put that in your calculator. Look at you use a calculator. Okay, you should get plus and root 8, 0.292. Okay, x is equal to -1707. Okay, remember to 2 decimal points. Okay, so x is equal to -0.29. Okay, remember we're splitting it there and then we're thinking about what that number is. If that last number, okay, if that third decimal point is above 5, or sorry, 5 or above, we round up. Okay, if it's below 5, then we keep that second number as is. Okay, x is equal to -1.7. Again, doing the same process. What's that third number? It's above 5, so that number before that rounds up. Okay, and we get -1.71. Okay, so we've found the two roots. So that's how you use that equation. Okay, if we go back into Desmosh, I'll just write that out. And I'll just show you what we've just found out. Okay, so that's the equation we started with. Okay, and that line in green is what we've just worked out. Okay, shape, because that's positive, it's a positive x squared term, we're getting that smiley face shape. Okay, where does it cut the y-axis? Well, it cuts the y-axis when x is equal to 0. Okay, so if we put x equal to 0 there, you get y equals to 1. Okay, here's your coordinate there. And then we've worked out where the roots are. Okay, so where it crosses the x-axis. So that's what we've just worked out, -1.707 or -1.71. Okay, and -0.293 or 0.29. Okay, so that's what we've just established there. So those 2 points there, those 2 key points there. Okay, any questions at this stage? Does that make sense? So you can see if we were factorising that, you would never in a million years be able to guess those 2 factors. Okay, never in a million years would you be able to factorise that just on your head, in your head. Okay, but that's what we've just found out. Okay, nice one. Okay, so I've mentioned that b squared minus 4ac bit, okay, a couple of times, and it's for a reason and we use it. Okay, now what they're saying this year is, well, I'll first tell you that b squared minus 4ac is called the discriminant. Okay, so oops. And it's a pretty important part of it. Okay, now because it's going under that root term, what you want it to be is greater than 0. Okay, so a positive number. Okay, and if it's greater than 0, what it tells you is there's 2 roots. Okay, so if b squared minus 4ac is greater than 0, okay, more than 0, okay, so 0 or above, it means there's 2 roots that are real and distinct. Okay, and what I mean by that, distinct. What I mean by that is the shapes that we've been seeing. Okay, Oops, that's meant to be our quadratic, or we've got something like that. And it means it cuts the x-axis in two places. Okay, so if we've got a shape like that, it means it crosses at two places. The two roots are real, so they exist, and they're distinct, so they're separate. Okay, now what usually occurs in that 5 is you usually get a question that asks you to describe the discriminant, i.e. say two roots that are real and distinct, or another way of putting it is if b squared minus 4ac is equal to 0, okay, then only touches the x-axis like that, okay, or like that. Okay, so that still gives you a root. So if you work through the equation, you would get one root. Essentially, you'd get one answer. Okay. Or it usually states that b squared minus 4ac is less than 0. Okay, so less than. Okay, negative. It means that the quadratic has no roots. Okay, no real roots. Okay, and that's type 3. So what that means, if we were to draw it out, we'd get a shape like that. Okay, so it doesn't cross the x-axis. Okay, so you don't have a root. Okay, so if it's less that, if the numbers are negative, then you're not going to get a result. Okay, similarly, if we had a shape like that, okay, you can see that doesn't cross the x-axis, so you're not going to get a result. Now this is important. So they've said they've taken discriminant out of the exam, but you can't take out of the exam because it's part of that equation. So this equation will still come up, but you won't have to describe the roots. Okay. Now, why am I telling you this? Well, that means that the discriminant that they give you or that we use has to be positive. Okay, it has to be positive. If it isn't positive, then we can't use that equation. Okay, because you're trying to square a root, which you can't do. Okay, so it has to be positive. So if you're taking out b squared minus 4ac and you're getting a negative, okay, it means you've done something wrong this year. Okay, so that part has to be positive. It has to be a number greater than 0. Okay, so that part I've taken out in red there. The number 8 is greater than 0. Okay, so that's correct. In this year's exam, it can't be negative. Okay, chances of them giving you equal to 0 are pretty slim, but it could come up. If it's equal to 0, then you only get one answer. Okay. Any questions on that? Okay. So a specific discriminant question won't come up. So if you're doing past papers, you still have to look at this. You still have to do b squared minus 4ac, but you won't be asked to describe the roots. Okay, you have to be given in that case something that will give you real roots. Okay, but you need to be aware of that. If that is negative, then you've extracted this part wrong. You've pulled something out wrong. Okay, and you need to go back and revisit that. Okay. I hope that makes sense. Okay. So you might see that coming up if you're trying a worksheet or a question or something along those lines. Okay, that might come up. okay, where you'll get b squared minus 4ac, it means you won't be able to find any roots. The roots don't exist. Okay. Let's do one more example, and then we'll have a wee 10-minute break. Yeah. Let's do it. Okay, wee example, and then 10-minute break. Example 2. Okay, so solving again, x squared minus 7x plus 2 equals 0. Okay, so it's in the form that we want. Give your answer to 3 significant figures. Okay, so remember the difference between significant figures and decimal point. Okay, it's pretty important. Okay, so this time, writing that out again, and then writing ax squared plus bx plus c underneath it. Okay, always keep these in the same form. That means a is equal to 1. Remember, we don't write it in algebra, but if there's a term, there's a wee 1 there. Okay. B, really importantly this time, is negative 7. And C is positive 2. Okay. So this is where we need to be careful. So we've got x is equal to negative b plus or minus the root b squared minus 4ac all over 2a. Okay. First step, as usual, I want to do is I'll just take this out and I'll just solve it at the side. Okay. So b is negative 7. And we're squaring that. So put that in a wee bracket like that, so we know we're squaring that whole thing. Minus 4 multiplied by 1 multiplied by 2. Okay, so a negative number squared, so negative 7 multiplied by negative 7. Two negatives make a positive, so that's going to give you a positive 49. Minus 4 times 1 times 2, that's minus 8. So that's going to be positive 41. Okay, positive number for that b squared minus 40c means there's 2 roots, means there's 2 real roots. Okay, so that means we've got 2 roots that we can work out. So you want that number to be positive. That's the only reason I do that wee bit at the side, but now I can put that back in. Okay, so we've got x is equal to negative b. Now b is negative 7. Okay, so we've got negative 7. Okay, plus minus root of positive 41 over 2 times 1. Okay.
This may be a stupid question, sorry, can I just interrupt?
Yep.
See the first bit where you have to find the roots, do you need to do that at all in this second bit, or is that different?
This bit here?
I'm just talking about like this second bit, because like see the first bit, like when would you do that then? Like finding the roots?
Oh, sorry, when we factorise?
Yeah, the first bit.
So there's 2 different methods of finding the roots. Okay, so there's method 1 and method 2. So it's an and or situation. It's not, it's an or situation. So you're using one or the other. You're not using both. So you either factorise or you use this equation.
Right, depending on what the question is asking.
Yeah, exactly.
Right, okay.
So if the question's asking for a decimal point, or if it asks you to find it exactly, or if it asks you to find it to significant figures, then you know that you're not going to be able to solve it using factorisation. Factorisation will give you a whole number.
Yeah, because that's what I was thinking. I was like, how on earth can you find the same answer using that first bit? Right, but it depends on the question. Cool.
Yeah.
That's fine. Cheers.
Over 2. Okay, so be very careful there. So remember, this bit is negative b. So if it's negative, it becomes a positive. Okay, so just be very, very careful. That's why we do this stage. Okay, just so you're really clear what you're putting in there. Okay, that's a really, really common mistake. Okay, so negative b, so negative 7, you're getting positive 7. We're splitting that into 2. And then we're just solving that in our calculator. Okay, so remember 3 significant figures. Okay, so what's a significant figure? That's a significant figure, that's a significant figure, and that will be a significant figure. Okay, so we split it there, and if we have to round it, then we use this number. Okay, so that x term is going to be 6.70. Okay, because the next number is 1, so we don't round up, we round down. Okay, x is equal to 0.298. Okay, again, separating that there. That's a significant, that's significant, that's significant. Okay, that's your 3 significant figures, and then we round using that 4th one. Okay, when you've got a 0 in front of the decimal, remember that doesn't count as significant. Okay, it has to be there, but it doesn't count as significant. Okay. Just going back to those 2 methods, that side by side thing again. Okay, if you used the quadratic equation for every single one of them, every single time you had to factorise, you would get the correct answer. Okay, it's only when it becomes, the roots become a decimal, it becomes impossible to factorise using that CDT method. Okay, so because it's impossible to do common factor, difference of 2 squares, or the trinomial method, okay, because it wouldn't give you a whole number, you would use this equation. Okay, but that equation always works. It's just the time taken. Okay. Nice one. Okay, going to give us a wee break there, just to have a wee look back at what we've written down. Okay, try and digest that a wee bit. Okay, about what we've just spoken about. I'll go through another example, and then we'll give an opportunity to just have a wee practice at that. Okay, we'll just have a wee practice at that. Any questions before we go on that break? Nice one. Okay, so let's take until 20 past, guys. Just clear your head. Okay, so we'll take it till 20 past. Okay, so I'll just go through one more sort of example. Okay, so same sort of setup, solve. Okay, but it could give you an equation which isn't fully expanded. Okay, so it gives you something along the lines of this and says solve that to 3 significant figures. Okay, and what's a wee bit problematic with this, that it doesn't immediately jump out at you as a trinomial, as a quadratic. Okay, because there's no sort of x squared term, and it doesn't end with 0 on the right hand side. So what it's looking for us to do is to break that up, okay, to expand that out, okay, and equate it to 0. Okay, so it's looking for us to expand that bracket, break that bracket, bring the 2 back over, and then solve as normal. Okay, so that's a little bit trickier to recognise. Okay, sometimes, but the format of the question, the setup of the question is important. You're solving that to 3 significant figures. What it's essentially asking you to find out is the roots of it. Okay, you're solving for x. So how would you solve for x there? Okay, well, you'd have to equate it to 0 and then go through it. Okay, so just look at expanding that. So I'm just going to write it out as full equation. Okay, and then expand it. So multiplying the first 2 terms, 4x squared minus 4x times -3 is -12x, and that's equal to -2. Okay, at this point, bring -2 over, change side, change sign. Okay, 4x squared, and now it's in a setup that's familiar to us. Okay, now it's in a setup that's familiar to us. Okay, now it's asked us to find it out or solve it to 3 significant figures. So that's the first indication that, look, I won't be able to factorise this using CDT. Okay, I can give it a go, but it won't work out. Okay, it's going to be to a certain amount of decimal places, so there's no point. Okay, so I'm just going to use our equation, and we're just going to go through the steps. Okay, so write that ax squared equals bx plus c underneath it. That means a is equal to 4, b is equal to -12, and c is equal to 2. Okay, and then we've got our equation that's given to us in the formula sheet. Okay, now we can substitute our stuff in. Okay, our information in. Negative b will be -12 plus or minus root of -12 squared minus 4 times 4 times 2. Okay, didn't make the root quite big enough. Okay, over 2 times 4. Okay, I'm just going to take this bit out and just do it to the side. Okay, and we do that for 2 reasons. To find out if it's positive. Okay, if it's positive, there's real roots. Okay, so -12 squared minus 4 times 4 times 2. -12 squared will be 144. -16, so 4 times 4 is 16, times 2 is 32. Okay, remember you'll have a calculator for these types of questions. Oh, that's not even right. Jeez, oh. 112. Okay, so it's positive, so I know there's 2 real roots. Okay, I can just substitute that back in. So x, and then tidy this up a wee bit. So negative 12 will leave me with a positive, plus or minus root of 112 over 8. Okay, then we're splitting that into two terms. Okay, we've got x is equal to positive 12 plus 112. Okay, so putting that into your calculator. Okay, I'll give you a second to do that. Putting that into your calculator, should get out 2.822. Okay, it's to three significant figures, remember? So that's your first significant figure, second and third significant figure. Do we need to round that third figure up? Nope, that one's below the number 5. Okay, so your first x term is 2.82. Your second x term, okay, putting that in your calculator. Okay, three significant figures. That 0 has to be there, okay, in front of the decimal, but isn't a significant figure. Okay, that 1 is your first one, that's your second one, that's your third one. Whatever that number is determines if you're rounding that third one up. Okay, in this case we're not, so 0.177. Okay, that's your two x terms. Okay, any questions there? So it's just that step, that added complexity step, where you're just having to break something up and expand it. Okay, again, nothing that we've not done. Okay, we did that in Unit 1, where we looked at expanding brackets. Okay, expanding brackets is a question that can come up separately as well, so you need to be aware of it. Okay, right. Let's have a wee look. Okay, in middle, the questions are in Pack 2. Whoa, geez, oh. Okay, the questions you can do or you can work through in Pack 2. Okay, remember you can use other resources, that's fine. Okay, but for quadratics, we're looking at Pack 2. Let's have a look. Take a bit of time and just walk through these just so you're familiar with them. Okay, difficult bit is just making sure you're putting it in that equation the right way. Okay, so that first b term has to be negative. Okay, so making sure that you've got that right term. Okay, what you're doing with that b squared minus 4ac. Okay, you don't need to describe that this year. So if you see any questions saying describe the discriminant, you don't need to do that this year. Okay, so where are we looking at? Right, here we go, here we go, here we go. Okay, so if you can open this up, guys, that would be good. Okay, this booklet just allows you to do them. Okay, so a couple of questions. So we're going to do more on this in regards to sketching them and drawing them out. Okay, so have a look at them. Okay, and see if it makes sense. Okay, but I don't want you. In fact, that first question isn't very good anyway. Okay. Miss question 2 out. Okay. So question, so 2.4, question 1. Okay. So it's giving you the answers, but it's asking you to actually just work through it. So these will be factorizing questions. Okay. So just working through those factors to make sure you can find out those roots so that this graph makes sense to you. Okay. This you can do if you want. Then here's some more factorizing. Okay, so factorizing. And then using the quadratic formula. Okay, so I'm on page 39. Okay, so using the quadratic formula. Okay, that's the formula that we wrote out. Okay, that's on page 39. There's a bunch of questions to do that. Remember the answers are at the back. Okay, so there's loads of questions that allow you to practice that. Okay, so page 39 and 40, plenty of questions there. 4C. Some towards the end there that allow you to rearrange it. Going to leave this on the board, okay, on the screen. Okay, so using the quadratic formula, give your answers to 3 significant figures. Have a go at a selection of these, okay? There's nothing in there untoward. Okay, towards the end you'll have to rearrange a couple, but nothing too bad, okay? So let's take 30 minutes. Okay, so work till 8:10, and then we'll come back on. Any questions? And then I've got 2 exam type style questions that I want to go through with you. Okay, and then we'll call it a night. Okay, so take 30 minutes working yourself off this question. Okay, using that quadratic. Remember, the booklet has answers at the back. So if you go into Moodle, open up that booklet. Okay, we'll have answers at the back for you. We'll come back together at 8:10. Okay, guys, 8:10. Okay, so have a wee play about in Desmos to give yourself a visualization. If it actually confuses you more, don't bother. Okay, that's just the first answer there. That's what you're looking for. So we're trying to understand where it crosses that x-axis. Now, I'm going to go through an exam question, type question, just to look at it in a slightly different way. Okay, or 2 exam questions we'll go through. Okay. So, as I say, it can be used, this sort of process can be used to find different values, okay, or check when different values are allowable in a certain scenario, okay. So with that in mind, we'll take a wee look at this sort of question, okay. Now this is a story type question, okay, where it asks you to find the expression, okay, and it gives you some wee bits and pieces that you need to put together. So we'll just take this step by step and see fact what that process that we've been working on tonight and on Thursday there, okay, how that process allows us to find out, certain things in this sort of scenario. Okay, so the first part of that question says find an expression for the area of the rectangle. Okay, so we've got a rectangle there given in the question. Okay, so if you're copying that down, taking a wee picture. Okay, we've got a rectangle there. And one side's given by 2x plus 1. Okay, and one side's given by x plus 8. Okay, so the length of it is 2x plus 1. The breadth is x plus 8. Okay, now it says find an expression for the area of the rectangle. So it wants you to write down, using those terms given, okay, that what the area of the rectangle would equal. Okay, now the area of that shape of a rectangle is just the length times the breadth, so it's those two terms multiplied together. Okay, so you can see by multiplying together you're going to get a trinomial or a quadratic, and by getting a quadratic we're going to actually use that process later on. Okay, so let's just look at that. Find the expression of the area of the rectangle. Okay, so yeah, area of a rectangle is just equal to length times breadth. Okay, so your two sides. Okay, so your area in this case would be your 2x plus 1 multiplied by your x plus 8. Okay, so I don't need that multiplication sign in the middle there. Okay, I can just put those two brackets beside each other like that. Okay, now the expression they're looking for wants you to break those brackets as well. Okay, it wants you to break those brackets. So if I break those brackets, okay, that just doing our FOIL. So the first terms, 2x multiplied by x would give us 2x squared. Okay, our outside terms, okay, 2x multiplied by 8 would give us 16x. Inside, 1x. Okay, and your last terms, what were not used. Okay, plus 8. Okay, just tidying that up, just collecting like terms, gives us an expression like that. Okay, so what on the face of it looks quite a bizarre question, quite a difficult question, find the expression for the area of a rectangle. It's actually not too bad. Okay, so we know the area of a rectangle is length times breadth. We're just putting that into an equation. 2x plus 1 in a bracket multiplied by x plus 8 in a bracket. Okay, and then we're just breaking those brackets up and getting that full expression. Okay, working through it to get 2x squared plus 17x plus 8. Okay. So second part of that question, part B, given the area of the rectangle is equal to that of the triangle, okay, so the area of that rectangle is equal to the area of that triangle. So I'll let you just copy that down if you're copying it down. Okay, so the height of that triangle is 3x. Okay, and the bottom of that triangle, the base of that triangle is 2 bracket x plus 5. Okay. So, given that the area of the rectangle is equal to that of the triangle, show that x squared is minus 2x minus 8 is equal to 0. Okay, that's quite an odd thing to put. Okay, so let's walk through what that's telling us, okay, or what it wants us to do. So we just write b here. It's saying the area of the rectangle is equal that of the area of the triangle. Okay, now we've worked out the area of the rectangle. So the area of the rectangle is just 2x squared plus 17x plus 8. Okay, the area of a triangle can be found by half times the breadth times the height. Oh. Okay, so it's wanting you to find that right hand side. Okay, so it's wanting you just work through that right hand side. Okay, so half multiplied by the breadth, which is 2x plus 5, multiplied by the height, which is 3x. Okay. Now, easiest way to do this, 3x squared. Okay. Would probably split that up first. Okay. And then tidy it up, multiplying it by the half. Okay, so another way to write that would be 2x plus 5, okay, multiplied by 3x all over 2. Okay, now that's quite messy to do, so you want to try and get rid of that denominator. Okay, now you could multiply that all out at the top, tidy that up, and then just divide each term by 2. Okay, or you could just get rid of that at this stage. Okay, like that. Okay, and that 3x multiplied by 3x. Okay, so it's a wee bit messy, okay, especially as I'm working down here. Let this out. Okay, so we need to be careful how we're breaking that up. Okay, so it might be easier just to break all that bracket out, break up that bracket and then multiply by 2x. Okay, so that would equal, so not 6x, 3x squared plus 15x. Okay, the left hand side hasn't changed at all. Okay, so every stage there, the left hand side has stayed the same. Okay, now we've got some terms on the right hand side. Okay, but what the question's asking us to do is bring both those terms together and have 0 on that right hand side. Okay, have 0 on that right hand side and prove that it makes something. Okay, so it wants you to prove that. Okay, and remember we did those proving things when we were looking at the trig identities. Okay, so we wanted to prove that the start is equal to the finish. Thing. So we want to end up with that term. So we want to finish with that. Okay, by working through. So we've got to this point. Okay, so we want to collect it all on the left hand side. Okay. So if I bring everything on the right hand side over to the left hand side, I'm going to get 2x squared negative 3x squared plus 17x minus 15x plus 8 is equal to 0. So I've brought everything that I had over here and I've brought it over to this side. Okay, that just means I can collect like terms. Okay, that just means I can collect all the x squared terms and all the x terms. Okay, so doing that, negative x squared plus 2x plus 8 equals 0. Okay. Now remember, when we're doing quadratics, when we're trying to work out for x, we want to get rid of that negative, okay, when we're working out the roots. So if we want to remove that negative, we just take that out as a common factor. We can take -1 out as a common factor, okay, and have x squared minus 2x minus 8 equals to 0. And that -1 just disappears because we take it to the other side. Okay, and that just equals 0. So that can just disappear. Okay, and we've ended up with that term. We've finished with what it's asked us in the question to find. Okay, so we've proved, okay, we found proof that x squared minus 2x minus 8 allows us to show that the area of the rectangle is equal to the area of the triangle. Okay, so given that the area of the rectangle is equal to that of the triangle, we've shown that to be true. Okay, now they're quite tricky questions in the way that they're written sometimes, but it's just a case of working through that step by step. So often they'll break it down into sort of A, B, and C. Okay, so A, we found the area of the rectangle. Part B said area of the rectangle equals the area of the triangle. So it wants you to find the area of the triangle and then collect all those terms together. Okay, and then part C asks us to find the length and breadth of the rectangle. Okay, so it will ask you along the lines of, for what values of x, okay, will this be true? Or find the value of x to allow us to find the length and breadth of the rectangle. Okay, so we're wanting to find essentially the roots of the equation, okay, and then use them to determine what the length and breadth is in this instant. Okay, so we are taking that equation in part B, and for part C, okay, we're just finding the roots. Okay, now in this instance, you could use your quadratic equation, okay, or if it's in the non-calculator, very good chance that it will just be a factorization problem. Okay, so if it's a non-calculator, it will be factorization. If it's in the calculator and it asks you for significant figures and it asks you for decimal points, then use the quadratic equation. Okay, in this instance, I'm just going to do CDT. Okay, there's no common factor, there's no difference in two squares, so I just want to do the trinomial. Okay, so I want to add two numbers together to make -2, multiply two numbers together to make -8. Okay, so I want a positive and a negative and a negative and a positive. Okay, I'm going to add them together. So -8, getting 1 and 8, 2 and 4, and that's us. Okay, to make -2, I'm going to have +2 and -4. Okay, +2 and -4. Just putting that into factorized form. Okay, so nothing that we haven't done before. Okay, it's just putting in a different form of question. Okay, so that's allowed us to find two factors. Okay, in this case, that'll be x plus 2 equals 0, x is equal to negative 2, x minus 4 is equal to 0, x is equal to 4. Okay, now in these type of questions, often the case that one of these roots work and one of them doesn't. Okay, so it wants you to establish if one doesn't work. Okay, so looking back to that original okay, move that down. Okay, looking back to that original rectangle, okay, we've got two values of x there. Now, it's asking for what value of x can we use to find out the length and the breadth. Well, if we substituted in negative 2 into these two equations, what answer would we get? Okay, so that x plus 8, okay, we could substitute in x minus 2 into that. Okay, and end up with 6. Okay, that would work. Okay, but if we put it into this one, we'd end up with a negative number. You can't get a length that's a negative. Okay, so we can't say that that side is a negative. Okay, so that doesn't work. That solution doesn't work. Okay, so the solution for this answer, for this question, must be that x equals 4. Okay. So when x is equal to 4, the breadth is equal to x plus 8, which is equal to 4 plus 8, which is equal to 12 in whatever units. Okay, so say centimetres. And the length is equal to 2x plus 1, which is equal to 2 times 4 plus 1, 8 plus 1, 9 centimetres. Okay, so we've established a length and a breadth. Okay, so the answer for this question, what is the solution? Okay, would be when x equals 4. Those questions will require a wee bit of practice. Okay, so at this stage, don't worry. Okay, if one comes up, have a wee look at it. Okay, if it's a calculator question, then use the quadratic expression. Okay, if it's not, just use the formula, the factorization. Okay, I'll start Thursday with another one of them, much to your delight. Okay, try and make it make sense. Okay, guys. I'll leave that with you. Any questions?